to be recording as of now. So we can start off. I always like to start these things with my usual spiel. If you guys weren't here for the metal guitar playing, show up earlier next time. But my name's Alex Dubovoy. I am one of the partners of a company called Verity, and I am a recruiter. Yes, it's true. I see a lot of familiar names. I see some I don't know, but if you all haven't been to the DevOps and Drinks meetups, I have no interest in recruiting any of you today. This is an event made for engineers. So I am going to politely exit the room. However, before I do, let you guys know, eventually, as we all know, everybody looks for a job. When you do, you might want to work with people who don't suck at what they do. I'm very proud to say we happen to not suck at what we do. So the company is Verity. If you guys have any questions on the job market, please, please, please hit me up in the chat privately, and I will be very, very happy to answer any questions that you have. We have Daniel and Chad over here. There are team members as well. You can hit them up. And also, since we are going to be giving away a bunch of free stuff, thanks to our friends at AKeyless, I'm going to provide a link. All right. And this link will then give us a sign-up sheet. And in the sign-up sheet, you give us your email, we send you all the spam, but we give you free stuff. We don't really send you all the spam, but we will give you free stuff. So we're going to do a drawing at the end of the event for two $50 gift cards, and looking forward to starting. So I'm going to go be quiet now. Ori, you ready to hit us off?
Yes, I am.
All right. From the great state country of Israel in the late PM. Ori, take it away.
Thank you, Alex, and hello, everyone. My name is Ori. I'm a VP R&D at AKeyless. Just a few words about what we do. AKeyless provides a secret management platform, secret and keys management, somewhat like Vault, but as a service. We deal with all kinds of secrets. If some of you are not familiar with the term, secrets are basically pieces of information that normally uses to authenticate to resources like username and password, API keys, tokens of any kind, and so on and so forth. It becomes a bigger problem when you have lots of ephemeral services that goes up and down, like Kubernetes and Dockers and other stuff like that. And then you need some way to store them in a secure manner. And today I'm going to talk about Kubernetes secrets, other ways to store them, more secure ways, show a little bit under the hood of Kubernetes secrets and some of the offerings. And if the time will allow, I will also show you some neat tricks on PKI authentication to Kubernetes, which is also kind of cool. How many of you just, I don't know, write in the chat or add a reaction, have heard or used secrets in Kubernetes or any other platform? Perfect, perfect. So I see a bunch of you already using it. So I would say that most of the modern DevOps tools have their own secret stores. If we're talking about configuration management tools, orchestration, and so on. But when you have lots of secret stores, then it becomes like secret islands. And you would want to have a unified platform to ease the management and the unification and the supervision and other parts of it. I will start by talking about Kubernetes secrets, and I will just jump right ahead and share my screen. And I have basically a small Minikube for demos here, and just a demo pod. And Kubernetes have what we call secrets, and you can use them. So some of the secrets are created by the application pods, by the users, and so on. And some of them are used for internal purposes, mainly when you deploy stuff, also in the control plane and so on. Creating secrets in Kubernetes is quite simple. You can just use create secret, something like that. Give it a name. Let's say call it test secret. And basically that's it, alone from the fact that it does not contain any metadata. So if I want to see it, I can do something like that and give it the name. Oops, just a sec. And basically in a YAML format, it does not contain any data, but if I edit it, I can also do something like that. And add some kind of data to it. And if I do it in that manner, I can give it a key. Let's say check. And the actual value, and it's important to say, it has to be base 64 encoded, which means that it's not really encrypted, right? Just a different representation. If I do something word like that, I can base 64 it and take the actual value and paste it into here. Okay, maybe we'll call it hello. It will be making a little bit more sense. And that's about it. This is how you create a secret. You can also create it from a YAML file. I think I have something here. And then you can deploy it. And this is the actual value. The name of the secret is very secret, and the value is the base 64 encoding of this value. I can just apply it. And there you go. Now, if I show my secrets again, and then you would see the new secrets, the test secret and very secret, everything is fine so far. However, I don't know how many of you know, but the secrets in Kubernetes secrets are stored in the etcd key value store in the same manner that you saw here, meaning base 64 encoded. So in the cryptographic word and encoding value, so you have the ability to decode it without a key, is equal to store it in a plain text, right? So let me see what I can do here. I can do something like that. So I'll go, since I'm using Minikube, but I can do the same thing in other ways. I can SSH into it and show the list of control plane containers, right? And one of those control plane containers would be the etcd. And I will try to grab it. There you go. And I can just do something similar to that. I can do docker cp and move this one from the file. I'll just paste the actual address. What I'm about to do is just to grab the database and pull it into a convenient environment for me to hack around it. Now I have a file called db locally. And if I run strings on it, on the DB, and I grab the very secret, this is the name of the secret that I created. What I actually see here in the database is the actual value, which is base 64 encoded, as I mentioned. And if I do the reverse operation, I can base 64 decode it and get the actual secret, right? So as you can all see, it's not super secure. There are better ways to store it. And one of the ways that we offer is our platform. And I want to switch very quickly to show it. We have a SaaS solution for secret management at AKeyless. You basically can create and manage all kinds of secrets. You can manage encryption keys if you're talking about symmetric and asymmetric keys, static secrets, which are username, password, or some kind of information that is rarely being changed, and all the concept of just-in-time access, which are composed of dynamic secrets, basically the ability to generate credentials on demand instead of fetching static ones, and issue certificates both for SSH servers and PKI, which can be used for various services, including Kubernetes. Okay, so what I'm about to do is to show you ability for us, for AKeyless, to use our AKeyless gateway in order to migrate secrets from different platforms into AKeyless Vault, meaning that I can connect to a Kubernetes cluster. I can give it a name. Let's call it my Kubernetes migration, just the name of the object. The server is that I'm about to use is actually running on the same host. I can try to do, try to fetch the values from here. And I can use various authentication ways to the Kubernetes clusters. I will choose the certificate because it's more convenient to me. And I can actually grab the certificate in this way and put it here. It's actually also base 64 encoded. And I can also do the same for the client key. And paste it here. This is the way I will authenticate to my Kubernetes cluster. Here I can choose if I want to migrate only partial subset of the namespaces. If I leave it blank, it will fetch from all the namespaces. And this one hints that I will skip the control plane secrets that I mentioned. This is the key that will be used to encrypt the secrets once they are being fetched. And this is a key that is managed on my account. And I can choose a target location. I can call it, just for the sake of the example, Kubernetes migrated secrets. I think I'm pretty much done here. So all I need to do is just save it. And what will happen is there's a sync in. If you blinked, you missed it, was just happening and done. And if I go to my account and refresh the page, I'm about to see, let me see here, the Kubernetes migrated secrets, okay? Now you can see that those are stored by the namespaces in different folders. And I will go to the default namespace, the one that I created, and I can see all the secrets, including the previous one and the new ones I created. This one I just created with you, the hello secret. And I can also view the actual value. It was Word, if I recall. And I can do the same for the very secret, which we hacked through the etcd key value store. And you saw already the value, and you will see it again here, but this time in a much more secure way. That's in short about how to migrate secrets from Kubernetes into AKeyless Vault platform. However, that's not enough. The fact that you migrate it, it's interesting, but how can you use them from within the Kubernetes application pods? So in order to do that, we basically created a Helm chart that installs a mutating webhook. It's basically a sidecar container that receives the events of pod being launched and can inject secrets based on annotation in one of two ways, either by mounting files in a virtual file system or using environment variables. This is pretty standard and requires no integration from the application side. So you don't need an SDK. You don't necessarily need an SDK or to integrate the secret fetching from within the code. You can just simply use or rely on standard ways to do that. I'll show you how it looks like. So what we have here is a couple of YAML files. This is the first one I will show. Pretty simple. It's actually a single container based on Alpine, very minimal version of Linux. And this uses two annotations. The first one is the AKeyless enabled one. This means that if we want to use the feature, the capability of injecting secrets into it. The second one is the method of injecting the secrets, and this is using inject file. And here you see a comma separated list of secrets, secret names actually, that are on my account. Just switch very fast to show you the actual secrets. So we have demo secrets. This is one of them. And the other one is my secret, if I recall correctly. Yes. So both of them are in my account. And what happens is basically just to demo that I'm able to fetch them and use them without the real purpose in this particular case, because the entry point is just running a shell script that echoes the actual values into the standard output. Okay, but imagine this could be any kind of application connecting into a database, for example, fetching some data from a secure location, and everything you have in mind works here. This is just merely for the example. The second example is quite similar, but uses environment variables. So it requires this annotation alone and a standard definition of environment variables, where typically you define the name of the environment variable and the actual value. But in our case, the value is another annotation that says that it needs to fetch a secret that is called my secret and demo secret. What happens, just to give you a glance behind the scene, is that we have an init container that basically translates the environment variables at runtime. So whenever it receives an environment variables, it checks if they have this specific prefix. And if so, when it goes and fetches the actual value and replaces the environment variable with the actual secret values. Pretty straightforward. I will show you how it works. So I will try and deploy this particular example. I will use the file one just for the sake of example. And I can see if it's already running, and it is. And I can just show the standard output logs and see that I already have the two secrets and the actual values of them. This is the first one, and the second one, if I go to the platform again, I can see basically the same thing. So this is the first secret, my secret, right? The second one was demo secret, and we'll probably show you the same thing. On top of that, one of the benefits of using a globally available and a unified platform is the ability to see audit logs. You can see exactly which kind of application, which kind of user access what, and when, and from which location. And if I kind of filter by the get secret value, so you would see that I have my Kubernetes that is running on AWS using the authentication method of AWS, fetch the two secrets, right? The demo secrets and my secrets, and then I manually fetch them from the web UI to show you that the actual value, this is me, right? So you have all in one place. You can see that if there are any kind of violations, if somebody tried to fetch a secret that is not authorized to do that. And there is also the ability to see kind of a visual representation of the activity, both in the number of secrets that you manage, the transactions that were done per time, geographic locations, and so on and so forth. And this alone can give you some insights to the type of secrets that are managed within the organizations. Any questions until now? Something that was not clear enough before I proceed to the next topic?
Seems pretty straightforward and very user-friendly, actually.
Perfect, happy to hear that. I mentioned at the beginning that we also offer the ability to do a just-in-time access using various methods. The third one is actually PKI certificate. PKI is one of the ways to authenticate to a Kubernetes cluster. It's basically defining a template. We call it a cert issuer with a set of arguments like the domain list and the TTL, or the time to live for the certificate, and more advanced features. But more importantly, it also indicates which kind of private key will be used to sign the certificate. And this is it. And this is also stored and managed by the platform. On the other side, on the Kubernetes definition, I will show it to you in a bit, we basically add the public key kind of to the trusted CA or certificate authority side of things. And this will allow me to force users to use signed certificate by the CA in order to log into a Kubernetes cluster. Why is it so important? Because in many cases, people work with Kubernetes in production, and you would want to have a very strict supervision about who accessing what and when, and even see an audit log to see what kind of actions and operations were performed by whom and on which time. And typically, if you use certificates, you normally grant a long-lived certificate, something that is lasting for months, a year, maybe more than that. And this is not very secure because you don't really have an idea about who accesses what. When using this approach and when providing a short-lived certificate, this means that once a certificate is being issued, it will only be valid for the next 60 seconds to log in. And afterwards, it will have to reissue another one. And then you have a very clear understanding about the activity, and you can prevent access, you can restrict the access to the Kubernetes cluster, you can grant it based on a set of role-based access control. And this is part of the things that we also support based on various authentication methods like XAML integrated with your favorite IDP, like Okta, I don't know, Auth0 and others. You can use authentication methods like native cloud identity management, like AWS IAM, Azure Active Directories, and other. And in my particular example, what I'm about to do is to connect to an existing authentication method that I created, XAML-based, and my identity provider would be Okta, to log into my Kubernetes cluster. It's actually the very same cluster, but this time it will be used from my own laptop. So I'm going to show you how I configured it. It's pretty much similar. If you guys are familiar with the way that AWS are authenticating to their clusters, you can basically define in your kubeconfig user commands. And in this command, I will use the AKeyless CLI, command line interface, to run this specific command, the get kube execreds, with the set of arguments like the cert issuer name, and this is the name of the cert issuer you just saw, and the key file path that will be used for the signing, and the common name. In this case, it will be the username of my Minikube cluster, and profile just for reference because I used multiple profiles on my environment. Now, when I run the kubectl get pod, what will happen behind the scene is this command will be executed. And whenever I run this command with the profile of the Kubernetes PKI, it will trigger the browser so I can log in with my identity provider. And this command will be hanging until then. Okay, so we'll see that in just a bit. So it's going through the auth service of AKeyless. It's taking me to my Okta. Obviously, I was already signed in, and this is not a very cool example. So I will maybe try to log out and log in again. But what you saw is actually that I see the very same pods. I will try to clear the cache so you can see the full process of it. Give me 2 seconds to do that. And I will sign out from my account. I just want to emphasize that because here you can use more sophisticated authentication methods like multi-factor authentication and any kind of user verification before you're able to log into the actual cluster, and voila. And if I go to my account, I can also see this very activity in the audit logs. So I generated the PKI certificate twice, and this is the actual email address that was associated with my identity provider account. So you can actually see exactly which individual ran what. That's in short. I hope I wasn't too intense and too fast. And if I was, then now it's a good time to clarify that with some questions, if you have.
Yeah, guys, please feel free to unmute yourselves and ask any questions you want. We love this part. Last chance questions. We got another shy crew here.
vSAN, vCenter server and all that might require a little bit of scripting. But in reality, it's just a couple of policy like everything.
I'm having difficulties to hear you. Can you get closer to the mic?
Set up and new software-defined names. We specify a few variable names. You know, we say which
But I can't hear you.
are connected to the talking about one that I already created. I want to connect my new SDDC to this subnet. And then we're going to say, you know, get my account, get the subnet, and then create a new SDDC. I run this command, and in a couple of hours, it's up and available for me to log into. So this is what it would look like to run a command like that.
The beginning of the question, I'm sorry, it was really, really muddy out there. We couldn't really hear you very well.
That's all there is to it. You let that thing run for up to 2 hours, and you can deploy.
I don't think they're talking to you.
Cluster.
They're just unmuted.
Yeah, I would mute them.
Yeah.
Or you explain, I have a question. Can you explain again how you do the environment variable injection and translate the AKeyless terms?
Yeah, so it's actually two moving parts to it. The first one is the mutating webhook, and I will show it to you exactly. So actually, if I run kubectl, I will get pod. I have a container or pod running in a different namespace called AKeyless. And this is a mutating webhook, which I installed using Helm chart, right? This one receives events on pods being launched and adds or mutates an init container that does certain logic based on the deployment. In the case of environment variable, what it will do is basically concat basically a shared object that translates the environment variable values at runtime to the actual secrets using an SDK that's running on the init container. So from the application pod perspective, no changes are required. We just inject an init container that fetches the actual secret value. And once the application, because it's a kind of a child process inherent the environment variables of the parent, and this is the parent process. So from the application perspective, it receives already the decrypted secrets as environment variables. But if you do a describe pod, you will not see the actual values because they are, as you can see on the actual YAML, represented just by the names of the secret, not the values. I hope I was clear enough.
Yeah, that makes sense. Thank you.
Awesome. Any other questions? Feel free to write them in the chat if you don't want to ask them, or just ask. All right.
We can do that offline, by the way. If anybody have questions, I can also share my email later on, and you can just ping me with technical questions. I'll be happy to take them.
Awesome. All right. Thank you so much for staying up late, getting this thing done, and preparing this awesome presentation. Thank you very, very much. We're going to take a quick 1-minute break. And don't forget, if you haven't registered on the link that I sent in the general chat, I'm going to copy it again and send it off. So please do register, and we will be picking a winner right after the final presentation. 2 winners, actually. So Ben, Lee, how do you guys want to start off? Who's going to go first?
And do you want me to go through the demo and then let you talk about how you're using Spinnaker?
That sounds like an excellent plan.
Awesome. Great. So let me share my screen. Oh, Alex, I think I need the ability to share my screen.
We could do that. Give it a go now.
All right. Great. So what I want to talk about today is being able to provide self-service to application developers as it pertains to continuous delivery. We're getting a lot of requests at Armory from our prospects and from our customers around the need with COVID that they're able to enable remote workers and provide visibility and transparency into the delivery process to allow the velocity of those teams to continue while they're working remotely. So something that we have integrated into Spinnaker that is a proprietary feature that Armory has built is we've integrated the open policy agent from the CNCF. And what we were able to do is we can integrate what we call policy-driven deployments. And the way that policy-driven deployments work is, I'm just going to open up this particular pipeline. And what you just heard from Ori is something that we hear a lot from our customers is, let's say somebody on the app dev side needs an environment variable and they decide to stick in their AWS secret and key in as base 64 encoded variables, and they store them as a Kubernetes secret. And what they want to do is they want to make sure that when somebody goes to deploy that they can actually block that deployment, because that's not a corporate standard and it would violate all of their audit policies as they move into production. So what you're able to do inside of Spinnaker is we can take what are called Rego files. And these Rego files is a domain specific language that allows us to go through and parse the JSON that's coming through a pipeline execution. And here, if I looked at, let's say, a trusted image policy. So what I'm going to do is I'm going to look at a particular pipeline definition. And inside of that pipeline definition, I want to see if we have any deployment manifests that do not start with these two different variables. And from these variables, what I can do is I can say, okay, if I try to pull something from, let's say, Docker Hub, which is not a approved internal registry, what we'll do is we'll actually fail the deployment. And when we look at the different ways of being able to do things, we can even go in and look at the orchestration engine. And here we have a package which allows us to look at specific events both before a stage executes as well as after something executes. So when we look at things like Terraform, and if Terraform's executing and you're going to see during an apply that the apply, if I'm going through that process, I'm only going to get specific variables on output. So what I can do is once I create something inside my infrastructure, I'll get a result back. And what we can do with Spinnaker is on that result, we can look and see if it is violating one of our policies. And if it is, we can automatically trigger a rollback of that particular deployment or of that infrastructure creation by using a Terraform destroy. And that will update our state files. It updates everything for us on the back end. And this just allows us to allow the app dev teams to self-service into their Spinnaker environments while giving them access to the delivery into AWS or into Google or into Azure, and creating their infrastructure as well as deploying their applications. We're giving them these guardrails into that environment. And the way that these end up running inside of our pipelines, let me go ahead and enable our policies here. So let me run this. So now what we're doing is we're storing each one of the Rego files in as a config map, and that config map will end up getting mounted as a file system element that will be loaded by our policy engine. And now if I go in and I configure here, I'm going to deploy a load balancer, and this load balancer is going to read in a parameter for the port. So if I go in and execute this, and let's say I'm going to do a successful one first, just so we can see that it will run. So right now we're deploying an element into our infrastructure, into our Kubernetes infrastructure. So here we can see that it was successful. I'm going to skip this wait state. And when we go ahead now, it's going to delete the manifest. So when we look at the executions inside of Spinnaker, here you can see that a stage inside of Spinnaker is broken up into multiple tasks. So around each one of these tasks, we have this pre and post that we can check with our policy engine. So now if I go back and I run this with port 22, what we'll see here is immediately, if we go in and look at the execution details, we're going to get a terminal error. And if we look at the deployment status, we're going to see that we have a policy infringement. Now, when you're thinking about building your pipelines, we see a lot of our customers where we're headed with enhancing this feature is when you're in a non-production environment, it may be perfectly fine for you to deploy something to port 22. Because I may need to exec into that particular pod as it's running. I want to be able to see some logs. I want to be able to see the path. I want to see init containers and see what other things and see so I can understand what's going on inside my environment. But then when I go through a release orchestration process, normally what we would do is we would go through some sort of change review process. And that change review process is something that's normally manual inside of an organization. So we allow our app devs to do whatever they want inside of their non-production environment. But when we get ready to release into production, we want to have a list of violations for this. So as you can think about what we're able to do with Spinnaker, if you've used Spinnaker in the past, we have things like Kayenta, where we can do performance validation of our applications. We can do canary analysis. We now have our policy engine. We can trigger data from that. You can have this integrated with things like overops and being able to get error rates and error logging from your application. All those things end up feeding into a decision support system that allows us to create sort of a grade. So one of my favorite tools of all time as an app dev has been Code Climate. And I love Code Climate because I can look at my classes and I can see a particular, based on audits of my code, I can see its grade go from an A to a B or from a B to an A. And we're looking at being able to do a lot of those same things with Armory's version of Spinnaker. So when you get ready to do a release, you'll be able to have an audit trail of being able to go back and see the historical context and the drift of the changes that are about to go into this particular release cycle. And from that, we can give it a grade. So you know with confidence as we get ready to push something into production that whether it's a Kubernetes deployment, a VM-based deployment, something that's going into something like Google App, based on all of those different criteria, we can come back and being able to show where you are in that release cycle to be able to give somebody a go, no-go decision about that particular release cycle. So I want to be able to give Ben enough time to be able to go through his presentation. So with that, Ben, I'll hand it over to you.
Cool. Thanks for that dive into that. That's really interesting stuff. Like Rigo's become such a nice system for writing those rules, and we're just starting to kind of scratch the surface of it ourselves. So it's interesting to see other use cases. Thanks for that. Let's see here. So I'll try to get my screen shared. Can everybody see that? Actually, before I do that, I want to take just a moment and just like make sure that folks kind of have an idea of what DataDog is. I guess I know hopefully most people know at this point. If you're in this room, you may have heard the name, but effectively, we are an observability platform with tons of integrations with different cloud providers, different different databases, caches, whatever you name it. We've likely got an integration for it. We like to make it as easy as possible for folks to get data into our system, and then more importantly, do something meaningful with it. So we work with logs. We have an APM product. We of course have our metrics and dashboards that made us kind of famous. So hopefully you've used our product or enjoyed it in the past. But yeah, so I'm from DataDog, and we're going to talk a little bit today about. Let me set up my screen. Can everybody see? Where are our faces? Where did
Not
faces
yet.
go?
Not yet.
No? Okay, 1 second. Oh, it's because I shared the wrong part of the screen. I'm a pro at this. There we go. Okay, there we go. Awesome. So yeah, we're gonna talk, everybody can see the slides now? Yeah, cool. Awesome. So we're going to talk about our journey with DataDog, or with Spinnaker at DataDog. And so we've used Spinnaker for a little over, closer to 3 years, 2-ish years, and Spinnaker and Kubernetes themselves have been really key components in enabling our growth. You've probably seen that we grew really rapidly over the last 3 years, and a lot of that wouldn't have been possible without Spinnaker or Kubernetes. And so what we're going to talk about today is a little bit about why we chose Spinnaker, what it brought us, and some of the challenges that we ran into along the way. So a little bit about me. I'm the team lead for the release engineering team at DataDog. I'm an industry veteran. I've been in the industry since the late 90s. I've done everything from rack and stack servers to, working on mail spam filter products in the early 2000s, all the way to like ThoughtWorks style consulting. And then of course, working on platforms like this and some hosting platforms in the past as well. And even built a deployment platform for a particular presidential campaign in 2016. And my journey at DataDog started 3 years ago this November. So actually this week, 15th was my 3-year anniversary, interestingly enough. So, and at that time I was kind of was brought in to help kind of realize our ideas for growth on the infrastructure side, particularly around deciding how we were going to scale out from our already large cloud presence. And so I came in to try to help figure out Kubernetes and Spinnaker, and not particularly in that order. We really kind of started with Kubernetes and then found Spinnaker to meet our needs, but we'll talk about that in a moment. So yeah, so largely this is a historical timeline of our usage of Spinnaker at DataDog, and just kind of some of the fun stuff that we hit along the way. Cool. So we're back in the year 2017. A lifetime ago to many of us. Gas was like $2.41 a gallon, and Spinnaker was, I don't know, probably in the open source world, a little over 2 years old at that point, maybe older, it could be wrong. And I think at that point, DataDog had just started to kind of test the waters with our usage of Kubernetes, and particularly Spinnaker. And we just started experimenting with it at that point. And then when I joined DataDog in November 2017, we were already experiencing pretty rapid growth, and no signs of stopping. You could say it was kind of like a growth problem, which I think is a pretty good problem to have in our industry. So no complaints. And yeah, and somewhere along the way, a decision was made to try to get DataDog running on Kubernetes. Like I mentioned, we were growing like crazy. So part of it was to help us kind of wrangle some of that growth. We had a fairly large cloud presence in one region, and we wanted to be able to scale out to many more regions pretty easily. And Kubernetes kind of some of the benefits were pretty clear in that regard. But we weren't really convinced that we wanted to just go give our users YAML and kube control and say, like go deploy to this Kubernetes cluster, or maybe 10, because if this Kubernetes thing was going to work, we'd want to repeat it. And we would need some sort of tool to not only kind of give our users guardrails to make sure that they can quickly roll back, for instance. We also wanted to make sure that they could do this at scale, potentially across many different deployments or many different regions, for instance. So at this point, hopefully most of you have an idea of what Spinnaker is, and I'll try to spare you the details, but it's a really awesome deployment tool. It spans a bunch of different platforms. As you can see, it's fairly easily extensible. So Armory is able to do some really great stuff with it. The Kayenta project, for instance, an awesome example of extending Spinnaker for better use, and then this work with OPA, which I think is definitely kind of I see OPA and these ideas as kind of a future thinking, like this is how we manage the complexity of these policies and stuff. So it's great to see Spinnaker used for stuff like that. So I'll try to spare you some of those details, but I'll say that what we're going to talk about is that like how we use Spinnaker. We didn't or how we decided to use Spinnaker, rather. We didn't just like pull the idea out of our hat. In fact, at the time we started experimenting with it, the Kubernetes driver was really it was pretty well in its infancy and had some rough edges. But we'll touch on that a little bit later. We of course, we evaluated other solutions. We have a pretty rigorous rigorous decision-making progress around these things. We don't make these decisions lightly. But the other solutions that we were digging into didn't really find that they were quite mature enough in terms in a few different places. So sure, I mentioned that Spinnaker Kubernetes driver was in its infancy, and it's like it had a few rough edges, but we were willing to dive in and try to help there, because what we saw was the Spinnaker community was already pretty mature, and the project itself was mature. It had been pretty well battle tested by way of Netflix and Google and other large companies using it at scale for what we would call, I guess, classic cloud workloads, not the particular Kubernetes variant. So we had some confidence in that, and that helped us make the decision a little more easily. And then of course it helped that Spinnaker had an established community and support network as a result of having a pretty rich ecosystem already. So because nobody likes to go into these things feeling like they're going to go in and blaze trails and not really have any help, especially when it comes to like a system like Spinnaker, which can get pretty big if you're not familiar with some of the concepts. There's a bit of a learning curve, let's be honest, but it's worth it in the end. And we knew that Spinnaker wasn't necessarily going to hit all of our needs right away, but we understood through some of our experience and some of our research that Spinnaker was extensible in such a way that we'd be able to figure out some of the things we needed to integrate with. For instance, like we wanted to get maybe some more rich metrics around like pipeline execution. So we tapped into Echo and Orca to get a little bit more data into DataDog platform, so we could do a little bit of historical rollup and various other things around like pipeline throughput and some other stuff. So like we found that those extension mechanisms made it really easy for us to do that. So that was another reason for us to say, yay, Spinnaker, good job. We can check this out. So yeah, okay. Going a little bit longer than I intended here. Sorry about that. But here we are. Let's fast forward to 2018. We figured out a lot. We figured out that Spinnaker is going to help us in a lot of different places, specifically for our needs around Kubernetes and just the support and community and other aspects that really drove us toward checking it out. At this point, we're running some pipelines. We probably have a few hundred pipelines going, but nothing real crazy yet. we're starting to operationalize some of our pipeline patterns through things like pipeline templates and other higher level abstractions that we'll get into a little bit later. But while we're doing this, DataDog's just continuing to grow. I know I reused the slide. You can shame me later. But we're continuing to grow, and our usage of Spinnaker is starting to ramp up really, really quickly. At this point, by the end of 2018, we went, from barely scratching the surface with usage. By the end of 2018, we probably had several hundreds of pipelines, and hundreds of executions a day. And that's when we started starting to see some growing pains. This is natural with the system that you're kind of early adopting, so nothing too surprising here. But I kind of want to go over some of that because it's kind of fun, makes it part of the narrative here. So yeah, so as we increased usage, we started finding some interesting scaling challenges, and the net result of that was that pipeline executions became really slow for our users. So pipeline executions that would normally take like 30 seconds to a minute with just a few steps against maybe one or two Kubernetes operations. Those things were starting to take 3 to 5 minutes, and in some really terrible cases, 12 minutes before they would error out. And it was really perplexing because we couldn't understand why the pipelines weren't progressing, and we didn't have a deep enough understanding. That we didn't do like some of our due diligence, admittedly, around how CloudDriver works. So once we got our head around that and started realizing we could take advantage of some of the scaling stuff on the Spinnaker CloudDriver side, it was a little bit late, but we also that helped us quite a bit, but also uncovered some other interesting bugs. So we're going to talk a little bit about caching now. Caching, as we know, is a contentious subject in computer science. It's hard stuff. It's hard to get right. We struggle with it all, like a lot of us struggle with it daily. But trying to get to the bottom of this performance issues, like a good monitoring company, we started looking towards our metrics, our logs, and we had started instrumenting Spinnaker with our APM product at that point as well. So that gave us quite a bit more insight. And we found that we found some interesting bugs. And what we noticed first off was that we were seeing some really large memory footprint from our CloudDriver caching nodes and our caching tier there. And as we dug in, we realized we were a bit over our head and could probably use some help. So we reached out to the community. And yeah, this is where the story gets kind of fun. So we reached out to the community, and we talked to folks on the Slack channels. If you're not part of the Slack community or Slack Spinnaker community, I highly encourage you to join that. It's been an invaluable resource to us. And then we were attending the special interest group meetings where we were talking pretty specifically about the Kubernetes driver. And we found ourselves in some really great pairing sessions with Armory folks and Google and some of the other folks on working on the core Spinnaker project. And what we discovered were that the Kubernetes v2 driver implementation had some kind of critical flaws in how it handled the caching. And the ultimate result of this was that the cache refresh step of a Kubernetes operation would never actually complete and would time out after 12 minutes. So that number of 12 minutes, as you can hear, keeps coming up. And incidentally, that is one of the main metrics that kind of drove us toward our let me make sure I get my stuff off there, toward our ultimate resolution with this particular bug. So it's interesting to point that out. So for the uninitiated, I'll try my best to describe how CloudDriver works at a high level. But CloudDriver makes a best effort to cache data about a given cloud account. So like an AWS account or a Kubernetes cluster, makes a best effort to cache that data to reduce kind of the round trip time for the UI, and also to reduce thundering herd effect on the APIs, and to generally just be more high performance and reduce bottlenecks. And so one of the strategies that it employs to kind of reduce the potential working set of a cache, because sometimes these cloud accounts can have gigabytes of data. Like a Kubernetes cluster can potentially have gigabytes worth of data worth caching. Same with AWS accounts. Really large installations can have tons and tons of data, and so CloudDriver tries to break those up and shard the data by breaking things up into caching agents, and those can be scaled out independently and have their own smaller work units. Well, what we found was the Kubernetes driver at these early stages wasn't actually working as intended. So kind of like with this classic wisdom, like around how the cloud driver works, we would assume that scaling out the cache workers to a greater like horizontally would give us more cache throughput. Hopefully, you reduce cache time, kind of based on what I told you and how it works. But what we found was that we were just like literally carrying copies of the same working set across all the agents. There was a bug that had the Kubernetes cloud driver caching agent actually not properly sharding. I won't go into too many details on that. It's kind of the patch wasn't actually all that big, but figured that out and determined also that like while trying to scale up, we were taking snapshots of this memory and running it through profilers and stuff. We also figured out that we had at least two, or I think it was n+1, so like 3 copies of the data in memory. So potentially large responses, like 200-300 meg responses, were copied many times in memory. And so what would happen is those caching agents just simply couldn't cache all that data and would time out after 12 minutes. And so that's why our users would get this 12-minute timeout. So we quickly isolated some fixes and got them implemented, and we're starting to see our cache refresh time metrics come down. Our users were happier, and things were starting to improve speed-wise for our users' pipelines, but we were still seeing longer than expected through our pipeline times. So the improvements didn't really stop there. While we've kind of stumbled onto this whole new class of problems at our scale that kind of brought to light some things that might not necessarily have come to light otherwise. So for instance, at this point, since we'd made a bunch of improvements like I talked about, but it still wasn't enough. And what we're seeing is that while we could scale out the agents, we would still see memory ballooning, long GC pauses, and even in some cases, some really large deployments would actually cause CloudDriver to so we'd run out of memory, crash the process, and then we'd have to, have some remediation to, replace that node or whatever. So along the way, what we figured out was that we could, clearly we could scale out the caching infrastructure to kind of its own. We did some more debugging and profiling, and we determined that one thing we could do is definitely like move the caching infrastructure to its own replicas, right? And kind of stop the bleeding that way, so we could survive the cache nodes being out. We still had read and write throughput via the read and write replicas, so we could survive that a little bit longer and give us more time to do some debugging. And so again, we got out the profilers, we got out the print line debug statements. We did everything we could. We worked closely with Armory, closely with Google, and some folks from Netflix to kind of hone in and zoom in on what the problem was. And what we found out was really fun. What we found out is those large responses from Kubernetes were not just not being properly sharded. We discovered that the caching agents were actually loading the responses into memory before serializing it. So we'd end up with 3 copies of it in memory, raw, in fact, and then a copy serialized. And so like instantly our brains go to, like, well, we got some ideas on things we could do to fix this. We could like, we could use streaming JSON, JSON library instead of, the standard object mapper stuff. And, ultimately we went back, but what we decided was we weren't the experts here. And we went back to the community and worked again with Google and Armory to kind of come to a middle ground, because which included, like a JSON streaming implementation versus the loading it all into memory, and a whole bunch of other fixes to deduplicate stuff in memory, and also to just be more efficient with our calls to Kubernetes. So the net win of this, of course, after we took all this data to the community, the net win of this, of course, is that all of that bubbles up to the world through open source, and even I'm sure some of this has been backported, hopefully, into Armory. If not, they probably did a better job. But yeah, so it wasn't long before memory was back to manageable levels. We were able to scale back. We also learned one other trick along the way that we could that is kind of like a break the glass scenario for if the caching infrastructure was struggling again. We came up with a break the glass kind of flag that lets you bypass the cache and talk directly to the Kube API servers. But I would highly recommend not doing that, as you will likely DDoS your Kubernetes API endpoints, especially if you have a large set of caching replicas. But it's there in the off chance that you need it. If you can scale down your replicas and can afford some hits against your APIs that are a little more aggressive, it's a thing you can do now, thanks to some of the work we did. Cool. So we're going to fast forward to 2019. Things are going pretty smooth. We've handled a lot of our major blockers, helped find some pretty major performance improvements, and we mastered the use of our pipelines. We have tons of pipeline templates. Adoption rates have skyrocketed. We're running many hundreds of pipelines a day. We're kind of on cruise control at this point. We even have some higher level scripts and tools to help us manage our instances, which are still in EC2 and kind of classic cloud deployments versus on Kubernetes. We still haven't made those migrations yet. We haven't quite migrated to the newer pipeline template stuff, but we got a pretty good thing going right now in 2019, and we're on cruise control. Of course, we had some light bumps along the way. Be careful to make sure you manage your pipeline execution history or risk memory pressure on Redis if you're using Redis for pipeline execution history. At this point, you should probably be doing all of that in SQL, but in the off chance that you are still using Redis, I highly suggest fine-tuning your pipeline execution history, or your users will have a bad time and not be able to load pipeline executions at all. And then, of course, upon reflection, we probably could use the DataDog product to figure that out, but the product was also evolving along the way, so we learned a lot. One other note is that the pipeline templates work really well for overall reducing the complexity of pipelines exposed to our users. And we found that it was really great, kind of like jumping off point for hiding some of the complexity behind doing multi-cloud deployments, for instance, from like one pipeline. Things can get kind of hairy in those pipeline templates, but we've operationalized that and built some tools around it, so it's less bad. But yeah, some of our YAML templates got pretty wild for these Spinnaker pipeline templates. But that said, we've been running fairly uneventfully for a year now. Scaling as needed, scaling back if needed, creating better abstractions around our pipeline templates and such. Cool. So here we are, we're in 2020 now. So now what? So I kind of want to go out on a positive note, because 2020 has not been great for a lot of us, and I don't want to go out talking about all the problems we had with Spinnaker. So I want to highlight that as of 2020, Spinnaker has supported our growth as an organization from roughly 300 engineers when we started introducing it to the team, to we have roughly 1,000 engineers now at DataDog, which is pretty great. We started with the goal to support at least one Kubernetes cluster production deployment. Now we have many dozens spanning tens of thousands of pods. And we're running somewhere in the neighborhood of 16,000 pipelines today with roughly 3,500 to 4,500 pipelines, depending on the time of day, because we dynamically generate pipelines as well. And I think that's pretty impressive. Like Spinnaker got us here through our explosive growth and really helped enable us. And we're super thankful, of course, for the community that I called out many times. Like we had, again, tons of great pairing sessions and working sessions with the Armory folks over the years, and Google and the other special interest group members, and again the Slack. I'm not as active there anymore. I've had a bigger project to come onto my plate, which I'll talk about here in just a moment. But I just want to say that if you do reach out to me there, I am logged in now. Sorry, Edward. I am logged in now, and I will be getting messages there. So if you want to reach out and talk to me about Spinnaker at DataDog, feel free to do that. So what's next for us? Like I mentioned at the beginning of this talk, my team still supports Spinnaker at DataDog today. That said, we're taking a bit of a different direction internally. And that means we're kind of turning Spinnaker into more of an implementation detail. And we're working to build a platform that will allow us, for instance, to do things like maybe call Spinnaker a set of Spinnaker pipelines, or maybe call a set of Helm commands that might apply directly against some clusters, maybe some Terraform. We've got some pretty big ideas that we're working on, and a lot of that is powered by the Cloud Native Application Bundle specification, which you can read a little bit more about at cnab.io. And we also recently, Datadog gave a Datadog On episode where we talked about our usage of CNAB internally and our what drove us to that. And yeah, I'd encourage you to check that out. And this diagram kind of shows you what we're thinking about as possible with these abstractions going forward. So. And if any of that's interesting to you and you want to talk more about release engineering at Datadog and what we're doing to make things safer, more efficient, and more user-friendly, reach out to me. You can get me at Twitter at BenjaminWS, or my email there, benjaminws@datadoghq.com. And again, in closing, grateful for Spinnaker and the Spinnaker community and how far it's gotten us. And we probably wouldn't be this far without it. So that's all I got to say.
Ben, thank you so much. Does anybody have any questions? That was a whole lot of awesome information before we do the raffle and then go back to our day-to-day. Any questions around the room? Fire away if you got them, please do. That was awesome. Anybody with questions till we give away free stuff? We ask questions if we give away free stuff before.
Go ahead and give away the free stuff. Maybe people will think about questions in the meantime.
All right. So as Ben was rocking the memes, those were fantastic, by the way. The cruise control got a huge thumbs up. We all like, thank you.
Yeah, I had to bring some memes. You're welcome.
I'm a fan. But thank you. If you guys have yet not to hit the link, I am going to send it one last time for the giveaways. So I am going to call out two names that I have randomly picked, and you guys have both won $50 a pop with thanks to AKeyless AI. So thank you very, very much for your generosity, guys. That was awesome. Let's see, we got Alan Valdez. I really hope that you have registered because you are the first winner. Yes, sir. And Dottie Nordberg. Dottie, you still with us?
Yeah, I'm here. Thank you.
You have won as well. So make sure that you register on this.
They're both registered. I checked.
All right. Nice. Nice. Jeremy, thanks for organizing everything. Ed, this meetup would not have happened without you. Once again, thank you very much. Lee, Ben, Ori, thank you so much for taking the time for the presentations. Again, my name's Alex. Alex, Danny, and Chad will hit all you people up on LinkedIn. So remember, be nice. Have a great rest of the day.
Thank you very much, Alex.
I'm gonna play some rock and roll on everybody's way out.
Nice.
Just because. Have a wonderful day, guys. Thank you very much.
Take care.
Thank you. Yeah, I'm staying for this. Yes.
Yeah. And I will play for y'all because I'm going to miss you people. Thank you very much.
Dude, that was nice. Nice SG in the background, by the way. I gotta say, it's a
Bye.
Alex,
guitar off my own heart.
keep the faith, man.